Okay, still going live. It says I'm live. Good morning. I'm so awake right now. Can you tell? You can't. You can't see my eyes. Oh, no, you can. Whatever. I haven't had the coffee yet, but still, we're going to go ahead with this. I got 4 people in the chat right now. So give me a hello so I see who's in there. And I'll go back to read the thing in a moment. This is AP Stat. We are going to be jumping into the first official lesson that I taught yesterday, but some of you saw it yesterday as well. Hi. Hello, people. People who were here yesterday are in the chat. That's strange. Okay, so I'll say this probably for the first few weeks, okay? But again, it's going to be a little bit weird as we move forward. I am not, you guys are in class today, which is Thursday. I'm not requiring you to be in the live stream for Wednesday. Same thing for my Wednesday students. If you are in class on Wednesday, am I echoing? So weird. If you, Wednesday students, if you're in class on Wednesday, you are not required to be in the live stream on Thursday, unless I say otherwise, of course. Like for example, last week, I saw you guys on Thursday, right? But I did not see the Wednesday kids last week. So I said, hey, get in that live stream for Thursday. So I'll make those appropriate announcements in Google Classroom when the time is there. So we'll figure that junk out. But now, again, with these lessons that I'm going to be teaching, I am going to be repeating the lesson. I am going to be trying to jam-pack more information into this like 70-minute block. Well, actually, right now it's like 65, but whatever, don't care. I'm going to try and jam-pack more information than I typically do. But if it's like, oh, crap, I didn't quite get that, perhaps join the live stream the next day. If you want to, that's completely up to you. We'll get used to this rhythm until they change everything, and then we're all virtual. So I'm excited. Okay, cool. But let me get my notebook. Let me do another pour of coffee, and I'll be back in like 30 seconds. I love that thing. It makes me feel like a stand-up comic. I just need like a brick wall behind me. Let me get that reference. Okay, never mind. Comedians used to do stand-up acts in front of brick walls. Okay. There we go. Give it a little notebook here. Well, that thing is boring. Let me do a little intro to you. And again, some of this is going to sound very familiar for those of you who have already heard it. Here's the deal. I often ask the question to my stat classes in the beginning of the year, what is statistics? A lot of people think they have an idea as to what statistics are. It's just a bunch of numbers. It's a bunch of percentages. It's a bunch of like, oh, mean, median, and mode or some junk like that. But no. I mean, yes, those are involved in the subject, but that's not what statistics is. Statistics boils down, in my opinion, to this simple statement. Statistics is making confident statements with limited information. I believe I said something similar to that last week. Yes, I'm going to go into more detail today. I mentioned soup last week, right? I'm going to go into more detail of that today. But it's making confident statements with limited information. How confident are you allowed to be? You can actually measure that. How limited? You can actually measure that. Now, in terms of getting this limited information, how do we typically get this limited information? This limited information typically comes from samples or polls. But these samples or polls have to be done in a precise way in order for them to be considered accurate or legitimate. For example, I'll just give you a ridiculous example. What's like a stupid website? I don't know. I'll just go like Facebook or some junk like that. No, Twitter. Twitter's a good example. Okay, Twitter's a good example. It's a dumb website. Let's pretend I have like 1 million followers and I put out a poll. Hey guys, what's your opinion on this? And then it's like 2 options. And I throw that out there. And really, I favor one option over the other, but maybe they don't know that. But here's the thing. If you're somebody who follows me for whatever reason, most likely you're going to agree with the things that I say. So if I throw a poll out there and it's just my Twitter followers answering said poll, that poll is not legitimate whatsoever. It does not reflect the true opinion of people in America. I could be like, look, 50,000 people answered my poll and it said blah, 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 blah. Okay, that's not legitimate because those people voluntarily, number one, follow you on Twitter, and number two, voluntarily answer said Twitter poll. That does not reflect the general opinion of people. Polls and samples have to be done in a precise way. Now, For example, I mentioned this in class about the presidential election. And I said, what, 140 million people voted in the presidential election. How many do we have to poll in order to get an accurate idea of Americans and how they feel about the presidency? Do you remember what the answer was? Roughly 1,000. Yeah, roughly 1,000. Again, there are very precise rules. Now, as to how you go about that, you don't just want to poll people, 1,000 people in Ocean County. That doesn't represent America. You don't want to poll 1,000 people in Barnegat. That clearly doesn't represent America. In order to get an accurate representation of Americans with 1,000 people, you would have to randomly select those 1,000 people. You have to randomly select those 1,000 people. Randomization is going to be the name of the game today. Randomization. I'm going to talk a bit more about the definition of randomization, what people think it is and what it actually is. But let me give you just another brief example. I didn't talk about this on Thursday, but I did talk about it in the live stream yesterday. Imagine Lake Michigan. I've never been to Lake Michigan, but just imagine Lake Michigan. And I tell you, I need to know the average weight of the fish in Lake Michigan. I need to know the average weight of the fish in Lake Michigan. Does it make sense that you would then, okay, catch all the fish in Lake Michigan? Heck no. You could drain the lake and then, no. There are crazy ideas as to how you would go about catching all the fish in Lake Michigan or weighing all the fish in Lake Michigan. But no, instead you have to take a sample. You have to take a sample. Now, let's say, okay, you go over to Lake Michigan. You throw your reel in, you start catching like 30 fish. Here's the problem though. If you're on the shores of Lake Michigan and you're catching the fish that are close to you, they may not be an accurate representation of all the fish in Lake Michigan. There might be some bigger fish deeper in the middle, farther down. You don't know. So in order to get an accurate representation, you need a randomized selection, not just what you could catch in that moment. Very strange. I mentioned soup. I love soup. I mentioned soup last week, and I'll kind of reiterate this thing. Imagine a soup bowl this big. That would be great. A soup bowl that big. You mix up all the soup. You do the whole thing. Now, again, that mixing that I just mentioned, that is your randomization. Once everything is cooked together and you have mixed that whole thing in. Now I need to figure out, how does the soup taste? Well, it's already been randomized, so I'm good. All I got to do is take like a spoonful or a bowlful, whatever. And that spoon or bowl full of soup represents a sample. The randomization has already been built in through the mixing. Crazy. I'll tell you a quick story. My wife and I were newly married, and I came home from work. She wasn't home yet. And she had left me a note. I got home like super late. It was like 5 or 6 o'clock. And she left me a note saying, there's a dinner in the fridge. It's chili. I'm like, cool. So I go in. I'm thinking about this because of the soup. And I go and I take out the Tupperware and I sit down on the couch. I throw in some sour cream and I begin eating it. I'm thinking to myself, this chili tastes terrible. Like absolutely terrible. Like what the heck, right? So, I keep eating. I get like through halfway and I'm like, I can't do this. But the thing is, I'm like only like a year or two married. And I'm thinking, am I going to really criticize her chili at this point? Yeah. So she gets home and she's like, oh, how was dinner? And I'm like, well, it wasn't that great. It was very thin. It just didn't taste good. She's like, what are you talking about? I had it earlier and it was delicious. I'm like, what? So we go into the fridge. Turns out I grabbed the wrong Tupperware. I grabbed a Tupperware of meat sauce for pasta. There's no real moral to that story. I just thought I'd share it. Anyway, ladies and gentlemen, if you do not already have them out, I'm going to need those notebooks out and open. Now, for those of you in the live stream, I'm getting ready right now. I'm at my desk. Oh, no, my glasses. That air conditioning might have kicked on, but it is not cool in here. Okay. Duplicate. Minimize. Bring this up. There's going to be various things that I get to. Ciao. and we kind of go from here. Again, those of you who are unfamiliar with how I'm going to do notes in here, this is typically the mode that I like to do because I like to have a hard copy of the notes. And by doing it this way, having a hard copy, if I were to move the piece of paper and someone be like, "Oh, I need to see that again," I have the hard copy that I could easily throw back up there. Now, for those of you in the chat, I'm not by the computer, but right now I'm bringing up there it is. I'm bringing the thing up on my phone. So if you're in the chat right now, it's kind of like a little Inception thing. I have the chat going right there on my phone. So that's a little weird. What is this? Did I comment that in the wrong spot? Wait a minute. Where did I comment that? Hold up a sec. 2 seconds. I got to go to Google Classroom real quick. Right? 7:30. Somebody commented on my thing. Hold on. Who commented on it? I got a comment on a Google Classroom thing from a student saying, "Are we meeting today?" And I'm like, "You're not in this class. So how did you even get that?" Whatever, I don't care. Let's go to this. No, I do care. I really do. It's just I do care. It's just I don't have time for it right now. So let's talk about this. This is randomness. People think they understand what randomness is, but they really don't. I knew kids in high school who, I got to change the cube over here. I knew kids in high school who were just like, "Oh, I'm random. I'm completely random. Butterfly." I'm like, that is not random. What are you talking about? You know, like you decided that you were going to try and be random, and you had a set thing in your mind that you were going to say that you were hoping people would then think that you are a random person. Thursday, September 10th. There we go. But that's not what real randomness is. I'm here to actually give you the definition as to what real randomness is, and we'll get to that. First of all, let me walk you through a series of thoughts. I mentioned confident statements with limited information. Confident statements with limited information. That is what statistics is. Furthermore, limited information comes from samples. That limited information comes from a sample. What is it called when you sample every single person within a population? It's a census. Yes, it's a census. I'm going to tell you right now, a census most of the time is a dumb idea. Most of the time. Most of the time, taking a census is a dumb idea. If I wanted to take a census of the United States, it would take me a long time. It would take me a lot of money. I don't have the resources for that. Every 10 years, the United States takes a census, but they have the money and the resources for that. I don't. I could take a census of all the students at Barnegat High School, but by the time I finish trying to get all of them, their opinions may have changed. A census is typically a dumb idea. If I wanted to take a census, you guys are cohort 2? Cool. If I wanted to take a census of AP Stat cohort 2, I could do that. Kind of, but she's missing, right? Whatever. I'll get her opinion later. But I could do that. I could conceivably do that because there's not a lot of you. But a census is typically a dumb idea. It depends on the context of the situation. That's actually going to be a word I'm going to say a lot this year. Context. Anyway, samples don't have to be incredibly large. They do not have to be incredibly large as much as they are random. have to be random. These samples have to be randomly selected. If the sample is not randomly selected, then you are introducing a key virus into the situation. If your samples are not random, then you are introducing bias. And the second that you introduce bias, you nullify the results that you have. You completely nullify them. For example, now I did this example yesterday. Just a quick show of hands, people in the classroom, who was here yesterday? I mean, not yesterday. Who was in the live stream yesterday? Just the three of you? Okay, cool. Then you don't answer this question. Okay, cool. Let me show you an example about randomness. Okay. Give me a random number. When I say number, I want like whole number, integer, stuff like that. A random number from 1 to 10. Okay. Where's my marker? Hold on. Let the record show that he said 5. Yeah, here we go. So 5. Okay. Give me a random number from 1 to 10. Okay. Give me a random number from 1 to 10. Okay. Give me a random number from 1 to 10. Okay. Give me a random number from 1 to 10. Oh, okay. Sorry, your hand was sideways for a second, so I couldn't really see what's going on. You can see that there? Yeah, they can see it in the chat. All right, last time. You ready? This is the big moment. Give me a random number from 1 to 10. Okay. You did not follow my directions. You're nodding yes. He did not follow my directions. For those of you in the chat, they fell for it yesterday too, didn't they? You didn't follow my directions. Do you know why? No. In the back of your mind, whether you thought about it or not, you believed that you could not repeat numbers. The second that you said 5, you made a choice, eliminating 5. Although I did say, choose a random number from 1 to 10. I did not change anything about my question. Theoretically, again, this is theoretically, you could have said 5, 5, 5 every time. And that technically would have been random. There's a comic strip about this called hold on. Comic strips are these like old like cartoons, they're like panels that they used to print in newspapers. Newspapers are these things that people used to read. Whatever, you guys are young. Yeah. But it comes down to the definition of what randomness actually is. What is randomness? Randomness is knowing what the outcome could be. Put this in big capital letters. It's knowing what the outcome could be, but not what it will be. See, the thing is, when I said pick a random number from 1 to 10, theoretically speaking, any of those numbers, 1, 2, 3, 4, 5, 6, 7, 9, 10, could have been chosen every single time. But then by you eliminating the 5, all of a sudden it's like, well, in your mind, you're not following my directions because now you're like, okay, I got to pick a random number from 1 to 4 or 6 to 10. You eliminated 5. It's okay. Everybody falls for that. Everybody falls for that. Okay, not everybody, but whatever. Let me show you what I mean. Calculator. Now, you don't have a graphing calculator. You have graphing calculators on your Chromebooks, but that's neither here nor there. That's not the purpose of this. I want to show you something on my calculator right here. This is a TI 83 plus calculator. You all have TI 84s on the apps on your Chromebooks. Under math, PRB, probability, there's a function called randint, which is really nice. You can pick a random integer from 1 to 10, but you got to make sure you type it in properly. And by doing this, the calculator gives me random integers from 1 to 10. 10, 10, 2, 6, 5. Now, clearly it repeated 10. It could do whatever the heck it wants, you know? Now, being that it's a random integer, being that it's a random list of numbers, if I were to do this again, if I were to do this one more time, then it should give me like a completely different random set of numbers, correct? Check this out. Random integer 1 to 10. 10. Wait a minute. 10. Wait just a second. 2. 6. 5. What is going on here? The calculator has a set list that it chooses from, kind of like a seeded list of numbers that it chooses from in order to produce what they believe to be random. The calculator is actually producing something called pseudo randomness. Pseudo randomness is fake randomness. It's fake. It's completely fake. I can seed this calculator to do whatever I want. For example, today is the 10th. I can seed this calculator. And now if I go back to rand int 1 to 10, by the way, the purpose of this is not for you to know how to do this. The purpose of this is for me to show you what real randomness is. 1, 2, 3, 4, 5, 1, 9, 2, 2, or 2, 9, 9. Okay, remember those numbers. I'm going to seed it again. Oh, I missed it. There it is. Nope, I missed it. There it is. I'm going to seed it again. And I'm going to go to rand int 1, 2, 3, 4, 5. And it gives me the exact same 5 numbers because it's pseudo randomness. Randomness in calculators is typically chosen from mathematical constants like pi. Pi is an irrational number, goes on forever and ever and ever and ever. That's just what it does. Where's my paper? There's my paper. But you could always have a calculator seated at any digit. You ever know somebody who could memorize 10,000 digits of pi? You do? You know someone? Yeah. Oh, okay, I gotcha. But yeah, these people memorize 10 for some reason. I don't know why. But random numbers do come in handy. So, ways to truly random. You could roll dice. Now, keep in mind it would have to be a fair dice, or fair set of dice, I should say. You can't have weighted dice. Weighted dice would mess you up there. You could use a spinner, as long as you're not trying to cheat with that spinner. My son tries to cheat with spinners sometimes. Next time I'm gonna try and remember to bring it in. If I don't remember to bring it in, we can still do it. But I got to bring in a hi-ho cherry-o. You ever play hi-ho cherry-o? Okay, it's a game with a spinner and cherries and for 2-year-olds. Anyway, you can flip a coin again if that coin is a fair coin. You could go to random.org. Random.org is how I do most of my randomness. Check this out. Random.org is how I do most of my randomness. The randomness on random.org is based on atmospheric noise, which is constantly changing. So it has a way of measuring atmospheric noise over the course of time, and as it changes the way that the random numbers are produced. So you could go integers. I want to generate 100 random integers between 1 and 10. Get them. Boom. And there's 100 random integers between 1 and 10. Just the way it is, Or you could even there's a list randomizer thing that I love to use sometimes. I do this for determining the order of fantasy football drafts and stuff, where I throw in people's names and I'm randomize, boom, and then it gives me a random list. But it doesn't give me the same thing over and over again. I mean, theoretically, it could give me the same list over and over again, but it is incredibly unlikely that it would give me the same list over and over again because it is supposed to be truly random. They advertise that on the website itself. They say random.org offers true random numbers to anyone on the internet. Now, I say it says true because, again, it's based on atmospheric noise. It's not based on anything that they do or they predetermine. But one of the things that, and actually, while I'm writing this, I am going to ask if you have those Chromebooks to break out them Chromebooks. But another thing that we typically use more often than not are random number tables. Can't see it, but there it is. In your Google Classroom, I should have shared a PDF with you guys the other day. Should have been 2 PDFs in the stream. One of them was a random number table, and the other was a worksheet that we're going to work through a little bit today. While you guys are doing that, while you guys are logging on, I'm just going to add a few thoughts to my notes right here, just so I can get these down. Graphing calculators are pseudo-random, meaning fake random, but that's just what they are, unfortunately. There's, like I said, there's a way to seed them into doing what you want, but that's neither here nor there. Unfortunately, we're in a time where I can't do the same things that I used to do in AP Stat. In the first marking period, after we got through the first few chapters, I would do a thing where I would set you guys up to go out and create your own polls, surveys, and to actually go out and randomly select students in the school to answer said survey. I can't do that this year. They're not going to allow kids to randomly wander the hallways and enter other classrooms unabated. Whatever. Some of you may have been accosted by my students last year. Yeah. Just saying. Teachers got mad. They did. Anyway, so here's AP Stats. I shared, there it is. It's had 9/9 worksheets, and then I have right here a random number table. Now again, these random number tables, I just want to show you very briefly how these random number tables are used. Obviously, I gave you 7 pages worth because, well, sometimes those things are there. Now, if I wanted random numbers from 1 to 10, I could be like, okay, 1, 1, 1, 6, 4. Look, random numbers from 1 to 10. Wait a minute. I'm picking single digits. How do I get 10? Right? If I'm picking single digits, like I got 1, 1, 1, 6, 4, how do I get a 10? It's a simple solution. It's right in front of you. What do you think? No. The rules are a random number from 1 to 10. Wait, you said add them together? No. How am I going to get 10 if I'm picking single digits? Pick a 0. I said random number from 1 to 10. So basically 1 to 9 represent those numbers that you are picking, but then 0 would be representing 10. And then when you get to a 0, you would just assign it to be a 10. And at some point, you get it. Now let's talk about 2 digits. If you're picking 2 digits at a time, then this is pretty straightforward. I get an 11, I get a 16, I get a 43. Notice I had to go between those 2 numbers there, but I get a 43 there. I get a 63, I get an 18, I get a 75. What the heck? What is this? What number is that? It's just 6. It's not 61. The 0's there. The reason being is this. 0, 1 is representing 1. 0, 5 is representing 5. 11 is representing 11. If you decide that you are taking 2 digits at a time, then you are not allowed to deviate from that. You have to continue taking 2 digits at a time the whole way through. Random numbers from 1 to 100. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's taken care of. How do you get 100? If I'm picking 2 digits at a time. 00. Mr. Markey, 00? It doesn't seem very likely to happen. 00. I mean, how in the world is 00 supposed to happen in a random number table? That's not even like common, right? Yeah, it happens like 1% of the time. 1 out of 100. All right. Oh, math and all of your weirdness. But that's basically the basic nuts and bolts of a random number table. You decide based on the situation How many digits are you going to take? Are you taking 1 digit at a time, 2, 3, etc.? Whatever you pick, you have to stick to that and you're not allowed to change. There has to be an assignment of numbers. Typically, you do have to account for those like double zeros or single zeros and things of that nature. It really depends on the situation. I'm going to go over an example with you in a little bit. I love random number tables. Is there a 000 up here anywhere? Because if I went like 1 to 1,000, oh my gosh, there is. It's right there. I did not expect that, but it is. It's there. Like sometimes that happens. Like what, 1 out of 1,000 chance. Okay. What am I stepping on? Okay. Oh, yeah, sorry. Your desk is going to be the one that gets caught by that cord most of the time. Okay. Oh, there I am sorry, I'm looking at the video of me up at the board. It's so weird. Okay. So now, let's talk about a simulation. I'm going to open up the other PDF that I have here. Oh, I should probably take care of my coffee before it actually like gets cold on me, right? That would be sad. Okay, back to this. Here's the situation. You should know that in AP statistics, you are going to be faced with problems that are just kind of nuts and kind of off the wall. Kind of like, what are they even talking about? Why would anyone even ask that question? That's this question. A large manufacturer of batteries knows that historically 10% of its batteries come off the production line defective and the remaining 90% of batteries come off the production line in working condition. Conducts a simulation to estimate how many batteries the company needs to pull off the production line in order to be sure of ending up with 10 working batteries. It's like the driest question in the world. But you're going to find out that over the course of this year, you're going to be faced with a lot of dry questions. And you, as an AP Stats student, are going to have to take that question and figure out how to mathematically answer that question or statistically answer that question. Now, the first question or the first statement that they want you to do is to describe how you will use the random number table to conduct the simulation. There are a certain set of rules, procedures that we follow in AP statistics in order to describe what they're asking for. So I'm going to have to come back to this question because we need a little bit more of information. Oh, so great. Okay, back to my notes. Wow. So, to set up a simulation, again, there are certain things that we need to do. We need to assign numbers to outcomes. Now, what's interesting is yesterday, when I did this example, I took 2 digits at a time. Today, I'm going to do 1 digit at a time. It's going to be slightly different results, but that's perfectly acceptable. You're allowed to do that. I'll show you what the 2 digits at a time would have looked like. But I want to do 1 digit at a time just to give you a little bit of a comparison, a contrast. So we have to assign numbers to outcomes. We are going to have to determine a stopping point. See, the thing is, when they are asking you to describe a simulation, let me zoom in on this. There we go. When they're asking you to describe a simulation or set up a simulation, you writing it out means that I would be able to come over, read it, conduct the simulation myself, and get the same results that you got without your help. I have to be able to understand what you're saying on the paper. You have to be able to communicate that information to me in order for that answer to be correct. It's going to be great. This will make sense a little bit. We are going to have to identify a response variable. Now, a response variable is the output of the simulation. It's the output of the simulation. Think of, you all been through Algebra 2, so you know about function notation. You're all very familiar with function notation, f of x. Only one of you are nodding yes. I didn't teach you Algebra 2, so I have no idea. But here's the deal. There's an input, there's an output. In statistics, It's the same deal. There's an input and there's an output. Typically, in statistics, when we get to two variable problems, the input is known as the explanatory variable, and the output is known as the response variable. It's the result of the trial that you are running. We're going to get there, but you have to be able to identify a response variable. Now, this is key. Repeats. Sometimes on a random number table, you are going to be faced with a repeated number. You are sometimes faced with a repeated number. Repeats are only allowed if dealing with percent. Repeats are only allowed if you're dealing with percentages. And the reason why I say that, oh, I'm sorry, I didn't mean to get on top of the desk with the thing. Whatever, I don't care. The repeats are a loud thing. Like, for example, there are, I can't even count, 7 of you in here right now. Okay. So I could assign each of you a number. I could be like, well, 1, 2, 3, 4, 5, 6, 7. Cool. Fantastic. What do I do about 8, 9, or 0? Simple answer. What do I do with 8, 9, or 0? If I assigned each of you a 1, 2, 3, 4, 5, 6, 7, and on the random number table, I get to an 8, a 9, or a 0, what do I do? You skip it. Literally, you just skip it, and you identify that in your assignment of numbers. But let's say I go on the random number table, which the one that we did. So the random number table that you guys opened, well, it started out with a 1, right? So it's a 1. So you get picked. Good job. But now I need to pick more students. What's the second number? Oh, crap. I can't pick you twice. Can't pick you twice. So I skip that number. That's the situation where I'm not allowed repeats if I'm dealing with like people or things assigned to those numbers. But repeats are allowed if you're dealing with percentages, which in this problem we are. We'll see. That's my walking music. You ever watch a TV show and like a character's walking down the street not saying anything and there's like music playing in the background, but that's the theme for that character? Yeah. In my head, I'm a TV show. Anyway, this is continuation of the same thing. I just had an additional note to do with there we go. There are more bullet points to that thing. You run multiple trials. How many trials, Mr. Markey? It depends. It depends. It depends on what the question's asking. It depends on what resources we have available to us. It really depends. In this particular problem, I believe they did the battery problem. They did want us to run 3 trials. And then in the end, you average the results and make a suitable conclusion. I'm going to tell you right now, the conclusions that you write are going to be very important. The conclusions that you write in statistics are going to be very important. The first several weeks of this school year, I'm basically trying to get you to understand how to write like a statistician. Writing like a statistician is very important. You are not allowed to make definitive conclusions. You are not. And you'll see this when I get to my conclusion later. Unfortunately, your conclusions have to be fluffy. They do. They have to be fluffy. It's like you're trying to take a stance, but you're not. But in the end, you're making a confident statement. You just can't be 100% confident. You can't. There's no way. Impossible. You ever seen a poll on TV where they say like, oh, the president's polling at like 45%, but the margin of error is like 3%, right? Margin of error is not a mistake. They use the word error, but it's not a mistake. A margin of error creates what we call a confidence interval. So if he's polling at 45% plus or minus 3, the interval that is created is what, 42 to 48? What that actually means, typically, they use a 95% confidence interval. I'm saying that I'm 95% confident that the true proportion is within that interval. You can never be 100%, ever. You cannot be 100% confident in this class. That sounds silly, doesn't it? You can never be 100% confident. I said that one year, and one girl looks at me. She's like, Ms. Markey, I'm like 1% confident in this class. No. Better than that. Anyway, so let's do that for this problem. Let's actually walk through what we need to do for this particular problem. Describe how you will use the random number table to set up the simulation. Now, I'm going to write this on the board, but I'm going to ask that you write the answers to this in your notes. Well, I said I wanted to do one digit at a time, okay? So using one digit, I would say, said 10% of the batteries come off defective, 10%. Okay, so let's let 1 be defective. No, let's let 0 be defective. Let 0 be defective. There's no rhyme or reason. You could pick whatever number you want, just as long as it's representing 10% of the numbers. As long as it's representing 10% of the numbers, that's fine. You can let it be 1, you can let it be 0, you can let it be 9, doesn't matter. But then I'm going to say let 1 to 9 be working. Good. I don't have to worry about repeats because I'm dealing with percentages. That's my assignment of numbers. Good to go. Okay. Stopping point. Ooh. I got to read this problem. Typically, the answer to a stopping point or response variable, those answers are within the paragraph. Okay. Large manufacturer, blah, 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 blah. Conduct a simulation to estimate how many batteries the company needs to pull off the production line in order to be sure of ending up with 10 working batteries. If I begin this simulation using the numbers that they gave me at the bottom or in the middle, when do I stop the trial? According to that sentence, conduct a simulation. According to that sentence, when do I stop the trial? 10 batteries that work. Yes. So hold on. I can't do this one-handed. This is weird. Look at that. There we go. So trial ends when 10 working batteries are pulled. Trial ends when 10 working batteries are pulled. Okay, that's my stopping point. What's my response variable? Now, the response variable is what's being reported. The response variable is the result of the trial. What number do we need to get out of it? Ooh. Let me reread the statement. Conduct a simulation to estimate how many batteries the company needs to pull off the line, the production line, in order to be sure of ending up with 10 working batteries. I'm kind of saying it like very like, what am I saying? How many batteries? Yeah, that's the response variable. So the response variable, and we need to identify that. The response variable is how many batteries pulled to get 10 working. How many batteries do we have to pull in order to get 10 working? There's a huge difference between that and the stopping point. The stopping point just ends the trial, but the response variable is what we need to report in the conclusion eventually. We'll get there. This is how we're going to conduct this simulation. So let me scroll. And come on, computer, with all of your computing. There we go. Now, clearly, in number 2, they just want you to do 3 trials. They just want you to do 3 trials. Show 3 trials by clearly labeling the random number table given below. Now, yeah, I don't know exactly how this is going to work in the future because I'm trying to give you as little paper as possible, but eventually I'm going to have you have a physical piece of paper with a number table and be able to work on that. But they typically want you to write on these and be able to show how it was done. So literally that would look like this. I'm letting 0 be defective. I'm letting everything else be working. So there's working, defective, working, 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 defective, working, working, working. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Cool. I got 10 working batteries. Literally, that's what you would do. I'm allowed to do repeats because I'm dealing with percentages. If I wasn't dealing with percentages, then I would have to do something different. How many batteries did I have to go through? Yeah. 12 is the response variable. I stopped when I got 10 working, but I had to report 12 as the result of that trial. Let's do it again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That was boring. It's only defective if it was a 0 because that's what I assigned it to be. 10 is the response variable. So let me go to here. Let's see. Oh, defective right off the bat. 1, 2, 3, 4, 5, 6. Defective. 7, 8, 9. Defective. 10. Is that 13? Hello.
Sorry to interrupt.
Sorry.
4 o'clock, you don't have class, is that right?
What is today?
B-Day?
I have B-Day. I have hall duty the first half.
Okay. There's a leak in
Yes.
Mrs. Connor's class. Is
Yeah.
it all right if she brings her 5 kids and uses this room?
Absolutely. Yeah.
Thank
Mhm.
Appreciate it.
Yep. Did you guys hear about that? Walked in this morning to the science. I didn't walk into the science room. I was following the teacher, and she comes out and she's like, "Oh," I'm like, "What happened?" She's just like, "Oh, the ceiling leaked." I'm like, "Ceiling leaked?" She's like, "Yeah, ceiling tiles fell down." Yep. I don't know how many years ago it was. It was probably like 8 or 9 years ago. Upstairs, A hall flooded. Yeah. Anyway, back to this. So I got 13 in this particular trial. It's fantastic. Oh, by the way, that was our principal. I don't know if you know that. Okay, some of you do. Yeah, that's our new principal. Okay. What a response, right? Anyway, back to this. Where am I? Okay. Literally, this is all I have to do for number 2. Follow my instructions. And the thing is, like, if I wrote those instructions out for number 1, I could give you those instructions, and then you can conduct this trial, and you would get the same result as everyone else, as long as you followed my directions. Let's look down at number 3, because number 3 is where it's at. Number 3 is where it's at. State your conclusion. And I am going to write this into my notes. I'm going to have to write this into my notes. The conclusion is the most important part. There are going to be certain phrases that we're going to be using throughout this year where we're going to have to write conclusions out. And one of the most common phrases is something along the lines of, you have evidence to suggest. You cannot make definitive statements. You are going to have to use fluffy language. This fluffy language is going to seem like a cop-out. It's going to seem like, oh, I'm not actually taking a stance. No, you're not allowed to when you're writing these conclusions. Your conclusions have to be fluffy. They just do. So let me go back to my notes. Take this with me. There we go. Ah, I'm going to trip and everything's going to fall. And then I'm going to crack my head on the floor. And I'm going to start bleeding. And I guarantee you when that happens, one of you is going to be like, oh, yeah, he called it. I'm implying that none of you will help me. But will you? Mr. Markey, is this a bit? Are you dead? Blood. What'd you learn in class today? I learned that no one will help Mr. Markey. Anyway, conclusion. Now, for our conclusion here, we got numbers of what? 12, 10, and 13. 12, 10, and 13. Just for the sake of argument, probably do this in my head. Don't feel like doing it. 10, 12, and 13 divided by 3, 11.67. So we average the results. I got 11.67. Based on the simulation of 3 trials, we got an average of 11.67 batteries pulled to get 10 working. Now, right off the bat, this is a statement. This is a fact. But notice the fluffy language that I used, based on the simulation. I'm not saying that everyone will average 11.67. I'm saying based on what we just did, based on the limited information of 3 trials, we got an average of 11.67. Come on, little thing. There we go. It appears what was it, a company? Whatever. The company should pull at least 12 batteries to get 10 working. And again, fluffy language. I use 2 forms of fluffy language in the statement. Number 1, I said it appears. Number 2, I said at least. See, the thing is, obviously, I'm reporting the average. I'm reporting the decimal average that I found from the 3 trials. But realistically, you can't pull a fraction of a battery. That doesn't make any sense. So when I do that second statement, yes, I am rounding up. I am rounding up in order to account for it. But again, fluffy language. Based on the simulation, we got an average of that many batteries pulled to get 10 working. It appears that the company should pull at least 12 batteries to get 10 working. Meaning, if I were working for this company, I would write up this whole thing. I would put out my conclusion in some kind of statement where I would recommend to the company, hey, recommendation to the company, pull at least 12 batteries in order to get 10 working. That would be my recommendation. I'm not saying that this is what will happen. I'm just saying that this is probably a better scenario than just pulling 10 batteries and hoping for the best. That's a lot of the stuff that statisticians do is they run simulations and they run statistical analysis on things in order to give advice to companies in order for them to make decisions. That's a lot of what statisticians do. Being a statistician, you can pretty much work for anything. I don't even know. So check this out. There's 2 major AP mathematics in high school. It's statistics and what? Calculus. Cool. A lot of kids come to me, Mr. Markey, what should I take, AP Stat or AP Calc? And the question that I ask them is, what do you want to go to college for? What do you want to go to college for? They're like, well, I want to go for this, statistics then. 90-something% of the majors that people tell me, I say statistics. The only time you'll ever really need calculus is if, number 1, you're going to be a mathematics major, like I was, or you're going in some form of engineering. If you're going in for some form of engineering, then yeah, you'll probably need calculus. But other than that, everything else needs statistics. Everything. It's the most applicable. I'm a math teacher. I can't say words properly. Applicable GOLO subject there is. Somebody say the word for me. Okay, you said it better than I did, so I don't even know. Okay. Let me stand up here. I'm all fogging up a little bit. Okay. My microphone. Dude, what is wrong with me? Okay, here's going to be the deal. After I wrap this up, I'm going to give a little conclusion to this whole thing right now. But after I wrap this up, I'm going to give you guys an opportunity with the time that we have, because again, we're here till 8:35. You might have 5 or 6 minutes. You might have 5 or 6 minutes. But in those 5 or 6 minutes, I'm going to give you an opportunity to get a head start on that discussion question that I posted into Google Classroom. Okay, but let me wrap up my conclusion like this. If you do not have randomness in your statistics, it doesn't matter what you're doing. It doesn't matter if you're running a simulation. It doesn't matter if you are conducting a sample. It doesn't matter if you are running a hypothesis test. It doesn't matter if you are doing probability. If you do not have randomness in your statistics, then your statistics are garbage. Flat out. That is a fact. You need to have randomness. You absolutely do. Just saying. Like I've seen these polls on TV, and again, not to call out any news channel, but like I've seen it on something like CNN, for example. CNN's like, oh, latest CNN poll, blah, 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 blah. And they report this as news. Okay, how was that poll conducted? Oh, well, we threw the poll up on our website and people came to the website and answered it. Okay. Any internet poll, any poll that you have to go to a website and actually click to answer it, as I said with Twitter, garbage. Completely garbage. Right off the bat. You know how many organizations organize like I don't even like trolling polls? Like if CNN throws up a poll and then like some organization on whatever end of the political spectrum, they organize and they're like, we're going to go to that poll and we're going to keep voting and voting and voting and voting and completely trash their poll. It happens all the time. It's so funny. Anyway, I had an example from way back in the day. You guys don't have any memory of like Total Request Live from MTV? No idea? All right, cool. Then that example means nothing to you. All right, shut up. It was a show where people would vote in and they would pick like the top music videos of the week or something like that. It was back in the day. But some guys trolled it and they got like a music video from like the 1980s thrown up on there. It was great. Anyway, you need randomness. Ladies and gentlemen, in the Google Classroom, I threw up a discussion question and there are some rules that I threw up there. So let me actually bring this up on my screen so I have some kind of reference for what I'm reading. Now, the purpose of this is to get you thinking about statistics and analyzing each other's thoughts. Oh, go to the quote. Here we go. Now, I do say read everything. Now, keep in mind, I'm not going to say that there's like a definitive right or wrong answer. Obviously, if your thought is original or trying to analyze something that is in your mind, and you throw it out there, sure, that's awesome. If you just kind of like, lazily, put up like some random thing because you think you're trying to, come on, be smart about this. So my expectations for you in the actual discussion: reply to the discussion questions that I have in your own words. I don't want textbook definitions or something you Googled. I want your thoughts. Don't try to sound smart. Don't do that. That's silly. I want your opinion. There are no wrong answers unless it's really ridiculous. Come back and like, obviously this isn't due until when? Like the 15th, which is what, Tuesday? Something like that? Yeah. So throw out your response and then come back at another date and read other student responses and critique them. Try to punch holes in their arguments. I will be commenting on your responses and I expect you to reply and adjust your idea to fix whatever problem I had with it. Now, again, this is not going to be graded. This is just a thought experiment. I want you to be able to critically think about these ideas that people are putting out there and try to punch holes in them from a realistic point of view. I expect you to reply sooner than the due date to encourage student responses. So here's the scenario. You have a team of 10 people. You will all be paid for 3 days of work as long as you produce what is needed. Your objective is to poll 1,000 voting age Americans on who they will vote for in the presidential election. Most polls, and this is true, most polls today are randomly generated or conducted through randomly generated phone numbers and actually calling the person, like cold calling the person. So what real life problems arise from cold calling people to get their opinion for a poll? What are some possible ideas for improving the way in which polls are conducted? I just said to you that internet polls are garbage. Just saying. How many of you regularly check your email? I'm sorry, your personal email. Probably one or two of you. One or two of you out of 7. All right. Just saying. Why is a website poll dangerous? I mentioned that, but obviously, bonus. This bonus is it's okay to not answer it. I just really want to know what you think. In 2016, there were properly conducted polls in Michigan, Wisconsin, and Pennsylvania, properly conducted polls in which Hillary Clinton was leading in those polls by 5 to 10 points in each of those states. She was leading by 5 to 10 points. But all 3 states went to Trump. Why were they so wrong? Now, again, that's a bonus. That's just a bonus. I want to see what you think about that. I do have a theoretical answer for that, but I'm going to save that for next week. I'm so excited. Anyway, you have roughly 5 minutes. Take some time. I think somebody already responded on there, on the discussion. Is anyone looking at it right now? Until I what?
Until we turn in our answer, you can't see anyone else's.
Oh, that's cool. Nice. So you can't see anyone's answer until you submit something. That's smart. I didn't intend on that. But I did put the thing where you can comment on each other's stuff. Yeah. So take some time, think about it. You could post multiple times if you wanted to. That's completely up to you. You could reply to your own post. I just want you to really kind of critically think about this. Anyway, 5 minutes. For those of you in the chat, I am going to sign this off. So, yeah. Oh, sorry. One last thing. I am going to post a link tomorrow in regards to Google Meet. So just as a heads up, obviously we haven't, what's the word I'm looking for? We haven't been taught a lot of stuff yet, but it's going to be there. Pop in. You can see my real face. Whatever. It'll scare you. I'm going to sign off in the chat now. Click and click. And then I got to set up a